unfortunately. All right, so this is most of the what we are talking about. This one, nitrogen, nitrite, those are one less oxygen. Okay, so now what if we have even one less oxygen? Okay, so now if we have another one less oxygen, in one less oxygen than ITE. Now, so this is one less oxygen than ITE, which means just to let you know, we don't have a lot. So you see, this case we have some of this has a one less oxygen, but just to let you know, not most of the elements we don't have the one less oxygen than the ITE. But for the fluorine, for the halogen group, they do have. Okay, for the halogen group, they do have. Like ClO2 minus, this is called chloride. And ClO minus. Okay, ClO minus, and this is called so this is one less oxygen over here. So if we have one less oxygen than the ITE, we're not going to changing the ending. Instead, we're going to adding a small prefix of there, right? Then we're going to add a prefix named hypo. So we just add the prefix in front of this. So they are going to still call the chloride, but instead of chloride, we're going to add one more thing, hypo, in front of. So this one is called the hypochlorite. Hypochlorite, okay? So this is called the hypochlorite. And BrO2, that's called the bromide. And the BrO minus, this is called a hypobromide. Okay, so we're not changing the ending. Instead, we're adding a prefix of there. And IO2, this is called iodide. And the IO minus, that's called hypoiodide. Okay, so you see, we're only just adding a prefix in front of this. We're only adding a prefix. Are you clear? Okay, yeah. So now, there's one more thing I didn't mention, but I'm not sure whether you already see the trends. Do you see? If we, for those polyatomic ion, if they are having the same anion, the non-metal species, when they change or increase oxygen, is the charge changed? The charge is not going to change. So this is a trend. Doesn't matter how you change the oxygen, the charge always the same. Okay, nitrogen with 3 oxygen is -1. With 2 oxygen, also -1. Okay, chlorine with 3 oxygen, -1. With 2 is -1. Even with 4, with 1, also -1. Okay, yeah. So this is trends. I mean, if they already have the 4, those are 8 is a -2, then they are, when they change the oxygen, they always -2. Are you clear? Okay, so this is a kind of the trends. Okay, yeah. Then in general, if you're trying to predict the charge for the group of those oxyanion, then you should be able to predict the charge. Okay, even it's not shows in your common ion sheet, you're still able to check this. Okay, one more thing I need to mention, which is the ClO minus. So this is a hypochlorite. You know, actually, everyone use the hypochlorite a lot in the laundry. Well, during your do the laundry, if you put the bleach in there, there's a lot about the ClO minus, which is a hypochlorite in there. Okay, so in general, and bleach, the major effect ingredient is hypochlorite. Okay, so you can using the hypochlorite to decompose those color molecules. Again, the reason they can bleach, make it a white, is because this guy, that's because all the color molecule, most of the cases, is organic molecules. Okay, so copper, the hypochlorite has a very strong ability to decompose those molecules, the color molecules. So when those color molecules be decomposed to several other small particles, then they're going to lose the function of those color. Okay, so they lost their physical property, right? Because they changed something new. Okay, so their original property is disappeared. Then that's why the color will be removed from your clothes. Okay, yeah. So this is a hypochlorite, and also you can also using the hypochlorite in when you're cleaning the toilet. It's doing the same thing. Okay, you know the toilet has, well, you know it, right? A lot of those dirts, and then if you want to clean, you can add the bleach in there, and then you clean it. Generally, you can make the every organic. It just decompose a lot of organic stuff. Then you come, okay. And there's one more I need to mention here. There's one more. Anyone knows the product is called Works? Anyone knows? There's a product called Works. Never heard of, never use it. Well, Works is very containing about like 5 to 10% the HCl, hydrochloric acid. It's pretty strong acid in there. Okay, so generally you can also using the Works to clean a lot of those inorganic dirts in the toilet. Okay, yeah. So the drinking water usually or the tap water containing a lot of the calcium. So that's a very, very hard. Okay, containing calcium. So when you're doing the shower, they more or less has a deposit, the calcium deposits in the surface of the anything. Okay, especially in the toilet. So you see, there's a lot of the hard dirt, hard stuff you cannot remove. That probably is calcium. Okay, participate. Okay, so that is why you're using the HCl. You get rid of the parts. Okay, yeah, very important. But here, the reason I'm talking about both HCl and the ClO, the hypochlorite, is because you're never put those two all together. That's gonna be a disaster. Okay, just let you know. I made this before, so I know it. Okay, yeah. So last time I put I'm going to clean the toilet. It has the organic dirt and also some inorganic dirt. So I'm just saying, okay, why not? Okay, HCl can clean the calcium, and the hypochlorite can kill the poops or something, the yellowish stuff, right? And why can I just put those two all together, then save time, right? Yeah, you can just clean them all together. But I failed. Okay, so if you put those two all together, the chemical reactions is going to generate it. They're going to generate a lot of the gases, and that gases is what is this? We learned this before. What is this? Cl2. We call this is a diatomic elements. What is this called? What is it? Chlorine, right? It's just chlorine gases. Okay, diatomic. This is the elements. So the elements is just the name of these elements, right? It's just chlorine gases. Cl2. They generate a lot of the Cl2, which is toxic. Okay, which is toxic. So and they're very, very corrosive when you inhale that into your lung. Well, so I put those two together. I try to clean my toilet, and then suddenly I see there's a lot of the gases in my restroom. Okay, and then I realize something bad happens. Okay, and then I have to, quickly just open the vent and let those stuff come out. Okay, yeah, very, very corrosive HCl, the CaO2. So never put the works and the bleach all together. That's gonna be very bad. Okay, very, very bad. All right, so this is just a side story to help you to understand those stuff. Okay, so this is a one less. Okay, one less oxygen than the ITE, and we add a hypo in front of that. We add a hypo in front. And then the next part, we're going to talk about if we have a one more oxygen. Okay, if we have a one more oxygen, have a one more oxygen than the ATE. This is not an ITE. That's a one more oxygen than the ATE. Then again, this is we're not going to add the prefix. Now we're going to add, we're still going to add a prefix, but this prefix is different. We're going to add the prefix, and this is it's called a per. At ending as a per. Okay, so generally this is only not so many compounds has this. Again, we saw ClO3 minus, that's called a chlorate, and a ClO4 minus, then we add a prefix, it's called a perchlorate. Perchlorate. Okay, and IO3 minus, they call the aldate, and then IO4 minus is called a peraldate. Okay, yeah, peraldate. Okay, so BrO3, that's a bromate, and this is a BrO4, it's called a perbromate. Okay, so generally this is a rule. And if you're looking at your common ion sheet, okay, in the first page, please go over there to looking at, there's a one more, it's called a MnO4 minus. MnO4 minus, okay? And if you're looking at the name, what's this name called? It's called the permanganate. It's called a permanganate, okay? So that means the MnO3 minus, what is that called? And this should be called manganate, right? This is called a permanganate. So MnO3 then should be called manganate. Should be called a manganate. Are you clear? Okay, yeah. And anyone knows what is the permanganate? Have you heard this? Potassium permanganate. Anyone heard the potassium permanganate? This kind of compound. I heard this when I was a child. Okay, so potassium permanganate is a very, very strong oxidant. Okay, very strong oxidant, and this color is actually KMO4. KMNO4 is a purplish color. Okay, it's a purplish color, and also when they dissolve in the water, it's just like this. Okay, it's kind of like a purplish color. Okay, this is a very strong oxidant. Okay, the reason where I know it is because when I was in China, I mean that's the 80s. During the 80s, China is pretty full. Okay, and we don't have those. I mean the people. Some people has the athlete foot. Okay, they have the athlete foot, and then we don't have the ornament that can cure the athlete foot. So the people just buy those potassium permanganate, and then they put it in water and dilute it, and then just wash the feet. Okay, yeah, immerse the feet inside of these solutions. Okay, and again, this is a very strong oxidant. In another word, they will damage your skin. Okay, make your skin aging very fast. Okay, yeah, but meanwhile, they can also damage the fungus. Okay, so then they wash out the fungus and kill the ethylene food. So usually this is what happened. But again, this is really bad treatment because it kind of like a damage everything. Okay, yeah. So that's why I remember this one. Potassium permanganate. Okay. All right. So this is the naming for those polyatomic ion. So remember, now recall. Let's just recall. We have a group of those elements. Go ahead, write down what is the name. Okay. Go ahead, write down what is the name. Okay, the first one, that's perchlorate. So that's a perchlorate. And then we have a chlorate. And we have this is a chlorate. And we have this one that's called a chloride. And this is a hypochlorite. Okay, here is doing same thing. They have a perbromate as a bromate, and this is a bromide. And this is a hypobromite. Okay, yeah. So this is a practice, and again, now we can be confident to name those ion, the common ion, sorry, we can name those ionic compound with the polyatomic ion, right? Yeah. So again, so if we have a metal ion plus not just a metal ion, cation, but most of the cation, that's a metal ion, plus the polyatomic anion. So you're doing the same thing, okay? Yeah, For example, you have copper, and then we have NO3. And if you're looking at this guy, so in this case, when you name it, then you need to make sure what is the charge for this metal copper, right? And what is charge for the anion? I mean, obviously, you know what's the charge for the polyatomic anion, right? Nitrate is a -1 charge over there. So you see, we put 2 over there, which means we're going to have a 2 of the nitrate to balance the charge for the copper. So obviously, the copper has a 2 positive charge, right? Because the compound is neutral. So that means this copper is a +2. And if you're looking at the common ion sheet, you know copper has 2 different kind of ion. It's copper 1 and copper 2. So now here is 2 positive. Then when you name it, you have to name it as a copper, and then you need to specify this is a 2, and then you write the anion's name, which is nitrate. So this is called a copper 2 nitrate. That makes sense, right? Yeah. And if you have the mercury, okay, and we have SO4 shows up there, okay. And if you don't know what is the charge for the mercury, since the mercury has 2 different ions, but you know what is the charge for the sulfate, right? Sulfate, you see, that's a 2 negative charge. And here we only have 1 sulfate. In another word, mercury also has a 2 positive charge. You see, we only also has 1 mercury over here. So that's why this one is called the mercury 2 sulfate. It's called the mercury 2 sulfate. Okay, and the next one, then you will see another one. Well, magnesium and sulfate. That's gonna be the complicate. First, okay, if we have the formula like this, first, how do we write if we have a magnesium and a phosphate combined? What is the formula? Well, we talk about, okay, say phosphate has 3 negative charge, magnesium has 2 positive. Again, you're gonna balance it. What you're gonna do, you're gonna put the 3 underneath of the magnesium, 2 underneath the phosphate of there. So the formula should be just Mg3 and PO4 2. Again, remember, we're gonna have a 2 of the phosphate, so you need to have a parenthesis to cover that parts. Okay, and what this call? Again, we just call the cation's name plus anion's name. That's it. Okay, don't have to specify how many numbers of that, because when you balance, we always balance based on the charge. So that's why for the ionic compound, we always specify the charge. And if you look at magnesium, the phosphate has 3 negative charge. So this guy 3 negative. And if you look at this, then you can calculate the magnesium actually is a 2 positive charge. And is there any charge for the magnesium ion? No. You see, you can look at this periodic table. There are only just 1. So magnesium only just 1 kind of charge. So you don't have to specify. You don't have to write magnesium 2. Okay. If this guy only have a 1 specific, 1 unique one, you don't have to specify what's the charge. So in this case, just write the magnesium. Just write the magnesium. So this is called magnesium phosphate. Magnesium phosphate. Okay, so now please go ahead to finish the question in the page 20. Okay, last time page 20 we worked on the formulas. Then now you can write the name for those compounds. Page 20. This is a time. You don't know this is common, not time. So this is but the point is, if you utilize the both of the outside, a problem has a two different eyes. One is called two. Again, don't look at this. The charge is the charge. The species number of the charge, not how many things are there. Then you need to specify okay, what is the charge for this. So that's why you need to go back and calculate what is the charge. Because this dog has a charge. Oxygen also has a charge. Oxygen here always is actually two. This dog has three of oxygen, which is a negative 6 charge. Then we have a two of balance. That's a two, negative 6. Then what is charge? So this guy has three contact cards. So that's we call Coleman 3. Okay. Okay. Now, so the two, we don't write two. Yeah. Because this is that's talking about chart. So this is Coleman 3 outside. Okay. Okay, so if you're done with this, you can, check with your neighbor, whether you got the correct one or not. Okay, yeah, let's see. Yeah, after 1 minute, I will also review it. Yeah, review the answer. Okay, so let's just review the name. Okay, let's review the name. The first one, that's a silver chromate. Silver chromate. There's no one shows up there. Silver only have one kind of ion. Then it's aluminum. Aluminum sulfate. Again, aluminum only just has one. Then barium hydroxide. Then calcium hypochlorite. Then it's a chromium 3 oxide. I know there's a lot of people will make this confusion. They said, okay, I need to specify the name of this chromium. Oh, there's a 2 shows up there, so I gave the name as chromium 2 oxide. No, okay. Again, this number shows up there is talk about the charge, not talk about how many numbers of this chromium they have in this compound. Okay, so this is a chromium. This guy has 3 positive charge. Oxygen has 2 negative charge. So this is chromium 3 instead of chromium 2. Okay, yeah. So this guy has 3 positive charge. The number 3 over here is the charge, not how many number underneath the chromium. The next one is copper 1. Again, not the copper 2. Copper 1 sulfide. Okay, copper 1 sulfide. Okay. The next one is iron 3. Nitrate. Very important. Those number is just to specify what's the charge. Next one is mercury. What do you think? Is a mercury 1 or 2? 1. Mercury 1. Okay. It's a mercury 1 because you see Hg2 2 plus, which means each of this, they have a 2 mercury out there, right? Each of this has 1 positive charge. And if you're looking at the second page of the common ion sheet, and they actually shows the name of the mercury. Mg2 plus, that means mercury 2. Mg2 plus, then that's mercury 1. So this guy is mercury 1. Okay. Mercury 1 chloride. Next one, potassium permanganate. Next one, lithium. Lithium carbonate. Next one is magnesium. Nitride, not the nitride, not the nitrate, not nitrite. It's a nitride. And with IDE. And the next one is sodium sodium hydrogen phosphate, and this one is showing in the polyatomic anion. Next one is a sodium dichromate. It also shows in the polyatomic anion. Next one is ammonia. Phosphate. Then it's a lead. This one is a lead 2 positive charge. So lead 2 acetate. The next one is tin 4 oxide. Tin 4 oxide. And then it's a zinc oxalate. Okay, so that's what we have. Okay, so let's take like a 3 minutes break, and then we will talk about the naming for the acid. Then we're done for today's lecture. Okay, so let's come back. Next part we're going to talk about is the naming for the acid. So first, what exact acid? So acid is different from the other compound. And just to let you know, acid is not an ionic compound. Acid usually has a hydrogen in front, but the other one is a non-metal. It's still a non-metal. So HCl is one of the acid, but if you're looking at this, HCl actually is not an ionic compound, right? Ionic compound we talk about is they have a metal and then non-metal. So the first one is a hydrogen. The hydrogen actually is not a metal, right? So HCl, this is not an ionic compound, but sometimes when this acid dissolving the water, they behavior like ionic compound, but they are not exactly a ionic compound. So this is a molecular compound, but we're naming, so that's why the naming is different. It's different from the ionic compound. Okay, just to let you know, this is not called hydrogen chloride. Okay, it's not called hydrogen chloride. So we give it a name for their specific acid behavior like acid. Okay, but for the acid, they always has hydrogen, like HCl, H2S. This is called the H2S. H2S smells like a rotten egg, which is actually the rotten egg also containing the H2S. The reason you think the egg is rotten is because when the bacteria decompose the eggs will generate H2S. So you can smell it. Okay, so this is another acid, and also if you see the HBr, HI, those are all acid. Okay, so this kind of the acid, they are having the hydrogen plus monoatomic anion. You see, right? They also only just one of the atom shows up, like a chloride, sulfide, bromide, iodine, right? Yeah. How about this? What is this? Water. Is this acid? No. Okay. Yeah. So although this guy also similar like the previous one, but this one is not acid. Okay. Acid is everything with the hydrogen first and an anion later, but not for water. Okay, water is not acid, but the rest of others are all acid. So this is a hydrogen actually plus a monoatomic anion, and this is acid. And some of the acid actually is adding a polyatomic anion like this: HCl, HNO3, H2SO4, H2CO3, and H3PO4. Okay, so this is also acid, but this is a hydrogen actually plus a polyatomic anion. Okay, so when we name those two are different. Okay, when we name those two are different. So first, let's looking at the first one. The first one, hydrogen plus a monoatomic anion, like a HCl. When we give its name, for this, we always need to add a hydrogen first. Okay, we always add a hydrogen first. So this one, we all add a hydrogen, not a hydrogen, we add a hydro, and then the space over here, that's gonna be the non-metal's name. And then the ending should be plus ic. Excuse me. Ic acid. Okay, ic acid. So this guy HCl is called the hydrochloric acid because this is chlorine, right? This is chlorine. You add rid of the RNE, then you add the ic acid. So this is called a chloric acid. I need to emphasize over here, okay, the hydro only combined with when we see the compound only have a monoatomic anion, then we add hydro, okay, not for a polyatomic anion, okay. So this guy is called hydro. You put hydro in front. So now you know H2S. Then this is sulfur, right? And this is called the hydro, but there's the sulfur. This one you don't have the right ending. Delete the ending. This is called the sulfuric acid. So this is called the hydrosulfuric acid. HBr is called the hydrobromic acid. HI, hydroiodic acid. Make sense, right? Okay, go ahead to name those two, H3N and H3P, okay? You probably never see this, but that's gonna be also one kind of acid, not rare. I mean, it's a rare one, but you still can follow the rule to give it a name. This one, definitely, they only have one polyatomic anion, right? Or the monoatomic anion. So this is a hydro, and this is called the nitrogen, right? You get rid of the ending and you plus the IC acid. So this is called the nitric acid, hydronitric acid. Hydronitric acid. And this is also this is a hydrophosphoric acid. Hydrophosphoric acid. Okay, so generally you're doing the same thing. Okay, you're changing add the hydro in front and changing the non-metals name and plus IC acid in the end. This is a monoatomic anion. Then if you have the hydrogen plus the polyatomic anion, this one is a pretty straightforward. Okay, but the major thing is that really depends on what kind of name for this polyatomic ion. Okay, so for example, if you have HNO3, H2SO4, and H2CO3, HClO4, HClO3 is doing the same thing. Okay, so those guys, what this called? NO3. What is the NO3 minus the polyatomic anion called? Nitrate. Okay, this is called a nitrate. This is called a sulfate. This is called a carbonate. This is a perchlorate, and this is a chromate. Chlorate. So those guys all ending with ATE, you see, right? Nitrate, sulfate, carbonate. So they all ending with ATE. So this guy, if they have the ending with ATE, if this polyatomic ion ending with ATE, so what we do is we're going to replace ATE to ic acid. Replace ATE to the ic acid, then that's it. So Nitrate over here is called, this is a nitrate, right? NO3 minus, that's a nitrate. You're getting rid of the nitrate and just changing that to ic acid. So this called a nitric acid. This is a guy called a nitric acid. So that's why I strongly recommend, and here I already said, so what is this called? H3N. It's called the hydronitric acid. What is this called? Nitric acid. So you tell the difference, okay? So that's why I'm saying, if they are adding just the monoatomic ion, then you're adding hydro. But if there's no, if it's adding with a polyatomic ion, then there's no hydro up there, okay? No hydro. So this is called a nitric acid. This is called a hydronitric acid. Okay, the same thing like this. Chlorate, so this guy is chlorate, right? Then you change the chlorate to ic acid. So this guy is called a chloric acid. And the HCl is called a hydrochloric acid. Okay, so that's the difference. Except the hydro, those are the same name. Okay, yeah. So this is called hydrochloric acid. This is called chloric acid. All right. So those are the same thing. This is called a sulfuric acid. And this is called a carbonic acid. Carbonic acid. And if you look at this one, it's the same thing, right? As long as the ending is ATE, they're doing the same thing. Although this guy is called a perchlorate, they have a prefix there, but generally their reading is the same thing. It's still ending with ATE. This is called a chlorate, right? Perchlorate, but the ending is still ATE. So you're doing the same thing. You're still changing the ATE to ic acid. So this is still got, this is called a perchloric acid. Okay, well, as long as the ending is ATE, then you just replace the ATE to the ic acid. That's it. Okay, so this is called a perchloric acid. Are you clear? Okay, yeah, so this is called a perchloric acid. Changing the ATE. Okay, all right. So this is the ending with ATE, and we know in the polyatomic ani, there's some of the ending with ITE, right? Some ending with ITE. So for example, if we have a hydrogen plus the polyatomic ani, ending with ITE. Ending with ITE. Like a HNO2, right? H2SO3. And this is HClO2. HBRO2 or HClO, HBHIO. That generally is the same thing, okay? And if you look at this, NO2 minus, and this guy is called a nitrite. This guy is called a nitrite. So if you're looking at this nitrite, you change the ITE, what we're gonna do? We're going to replace ITE to OUS acid. OUS acid. So this is called we change this to OUS acid. So this is called a nitrous acid. Nitrous acid. Okay, so change the ITE to OUS acid. So this is called a nitrous acid. And this one is this is called a sulfite, right? You change the sulfite to sulfurous acid. Okay. All right. So now it's your turn. Please go ahead to finish the name for those the last four. Okay. And you can go ahead using the common on sheet to looking at it. The better to figure out what is the name for those polyatomic anion, and then change that ending to OUS and acid. So if you're looking at this ClO2 minus, they have a ClO2 minus. This is called a chloride. This is called the chloride. And then this with hydrogen, you change this ITE to acid. So this is called a chlorous acid. Bromine over here, and this is called a bromide, right? Bromide is not in the polyatomic anion, not in the common sheet, but you should base on the rule to get it. This is called a bromide. Bromide, you change this OUS, then acid. So this is called a bromous acid. And this one also HClO. ClO, we also call this has a prefix hypochlorite, right? Hypochlorite. Hypochlorite, you change the ITE to the OUS and acid. So that's just a hypochlorous acid. Okay. IO, that's the same thing. This is a iodide. This is hypo because they only have one oxygen. So hypo iodide. Then you change the ITE to OUS acid. So this is called the hypoiodous acid. hypoiodous acid. You see? Yeah. So those are how we name those compounds. Again, one is a plus with a monoatomic anion. One is a hydrogen plus the polyatomic anion. They are having the different naming ways. Okay. The very special one is the monoatomic anion, you put a hydro in front. Okay, you have to put the hydro in front. Okay, so generally we're done for today's lecture, and then we're going to work on the practice.